Hi folks, remember that video, the last video I made? That's the one, that's the adapter, It is 6.5A at the amperage and 24 volt. What does it do? It is go for the company specification actually from the factory, and it's reach up the Z-axis spindle is reaching up to 11K 0.25. So it's almost the same specification, but what I find out with this adapter is no torque. It is going fast 11, but if I put my finger, it's really stop. It is actually good for this kind of spindle. It's worked fine to make PCB, and this was my first target. But as long as I got a small little beast, I'm thinking why I'm not using the small beast a good teeth, which is a nice spindle over here. It is 40,000 RPM. There is many kind, we will get to it. Anyway, when it's not stopping, when it's just speedy, and try to stop, so I give another amp more. So I brought this adapter. It is almost, it is almost 10 amp. That's different. Okay, so 10 amp, 24 volt, 10 amp, almost the same size, can fit easily to the enclosure. Okay, this is the controller for the spindle, and this adapter actually it was for the controller itself, for the which we will go through with. Now look for example here. You see what's doing. I tried to tune it many times. I could not. I mean, the speed and feed and everything. It is with. It's not working with this. You are talking about 2 mm only from the BDF, right? Okay. Now I change the adapter 36 volt 10 amp for the new spindle. That's the new spindle. Let me open the new spindle and show you. Actually the Z-axis, the bracket, it is 5.2 that means 52 mm, and this one 42 mm. So I have to do some spacer. I do it with the lathe. Okay. You can see that the spacer is aluminium. Before I put it back, I want to show you something. That one, the cobbler, it's to hold the stepper motor with the lead screw. It's ain't good. It's give me wrong reading. So I change it with solid one. I do it with the lathe. Okay. Let me return it back. Okay, what we have done with this upgrade, it was, now I think I can cut the wood and aluminium, because this one is 40,000, there is 60,000, there is 24,000, 24K, and there is 40K, and there is 60K, so I take the middle one, it's 40. Okay, so there is two filter over here. This filter is going, one of the filters going for the adapter, and I put ferrite. Sometimes the screen, when I start the driver or the spindle, it's blank one time only. That will be fine with me if it's only when I start it. Okay, it is good. So you notice there is a noise because everything is close to each other, and I got almost 5 adapters. Let us check the adapters. I played with the adapters. That's why I'm thinking to do not put the link, because it is dangerous that somebody play with adapters and he don't have a knowledge with it. So I got this for the small PC, the computer, and I got this adapter. It is for the controller, and this for LCD, and I got adapter for the drivers, and I got adapter also for the spindle. Okay, the adapter there, and this is the controller or driver for the spindle, sorry. Okay, this one, these inputs we got here, we got for the X axis, Y and Z. We got limit switches, we got the spindle, and we got the LCD. So all of them 6. All right, what should I show you more? Okay, here we got the mouse. We got for the mouse, this is, I'm using the mouse. You know, you should not use any wireless item like the mouse or the keyboard as long as controller. It is not advisable at all. Okay, this is the where I put the USB for any code I need. Right. What kind of change I made also? You see, there is no space. It is up to the end. So I remove the connector from the adapter. I put it in the top. I put another connectors, and I cover it with print, 3D print cover. Okay, let us start first, and we'll check what sound, what is the sound and how it's going to be. Now this is for the driver, and that one, see, it's blink for one time only, right? What does it do when it's blink for one time? Meaning there is a noise. So if I did not put the ferrite ring, which is I show you over here, you see it, the green one down. This tachometer actually is measuring the current. It's not measuring the RPM. Note that. So if I try to make it like this speed, it's almost 20k. So you have to use the tachometer and then write down the current with the speed, and after that you know exactly what's the RPM you go through. For example, I can show you now. You could see it's 20k. That's the speed of spindle. I love this spindle, really, very smooth, very nice. There is 24k, there is 40k, there is 60k. So I choose the 40k. It's enough, I think, to cut the aluminium. So this, of course, it will give a voice when fraction with the material like the aluminium and wood. It will give different voice, but as long as it's smooth, like especially it's air cooling spindle, it is kind of quiet. Okay, let me shut it off. Okay, I'm talking about, I will talk a little bit about the potentiometer for the people who's using the potentiometer. Uh, if you're using potentiometer, it is the speed for the spindle is going to be one. Some projects or some G file, G code file, uh, the speed of spindles change. But if you're using this one, it will be continuously uh, give you the same speed, right? The only thing with the controller is just the controller working with M3 and M5. That means starting the spindle and stop the spindle. Connected, of course, with the controller or the driver for the spindle. Anyway, I want to check the x-axis and y-axis. Let us start with y, for example. Right. See, this is really muscle. I mean, it needs really good spindle, not for the BCB. Yeah, yeah. I want the old one. You know, because it's strong machine, it's break so many bits. I mean, 3 or 4 bits have been broken because it is strong. It's chipped like plastic. My God, this it is a finish. Anyway, and this is the x-axis. And let's check the z-axis. You see it? Right. Everything working perfectly now with this machine. That's it, folks. I hope I will make more projects to show you from this, and of course I need to cover it up. I got the cover over here, and it will be fine. Thank you, folks. That's it.